equation. The Nernst equation allows us to predict the cell potential for voltaic cells under conditions other than standard conditions of 1 molar, 1 atmosphere and 25 degrees centigrade. The effects of different temperature and concentrations may be tracked in terms of Gibbs free energy, that is delta G. This free energy change depends upon the temperature and concentrations according to the equation delta G equals to delta G naught plus RT ln Q, where delta G naught is the free energy change under standard conditions and Q is the thermodynamic reaction quotient. The free energy change is related to the cell potential E cell by delta G equals to minus NF E cell. So for non-standard conditions, minus NF E cell equals to minus NF E naught cell plus RT ln Q, or E cell equals to E naught cell minus RT ln Q by NF, which is called the Nernst equation. The cell potential for a voltaic cell under standard conditions can be calculated from the standard electrode potentials. But real voltaic cells will typically differ from the standard conditions. The Nernst equation relates the cell potential to its standard cell potential. E cell equals to E naught cell minus RT ln Q by NF, where R is equals to gas constant equals to 8.314 joule Kelvin inverse mole inverse, and T is temperature in Kelvin, and Q is thermodynamic reaction quotient, and F is Faraday's constant, and also N is number of electrons transferred. The quantity Q, the thermodynamic reaction constant, is like a dynamic version of the equilibrium constant, in which the concentrations and gas pressures are the instantaneous values in the reaction mixture. For a reaction, AA plus BB gives CC plus DD. Q is equals to concentration of C to the power C multiplied by concentration of D to the power D upon concentration of A to the power A multiplied by concentration of B to the power B, where square bracket of C is understood to be the molar concentration of product C, or the partial pressure in atmosphere if it is a gas. Applied to the Daniell cell, where zinc and copper form the electrodes, the reaction is Zn plus Cu plus 2 gives Zn plus 2 plus Cu. The form of Q is Q equals to concentration of Zn plus 2 upon Cu plus 2. As we know that concentration of Zn and Cu are considered to be constant. Since the concentrations of the pure metal solids are assigned the value 1, this implies that the departure of the cell potential from its standard value to 1.1 volts will be influenced by the temperature and the ion concentrations. Text, where R is gas constant equals to 8.314 joule Kelvin inverse mole inverse, and T is temperature in Kelvin, and Q is thermodynamic reaction quotient, and F is Faraday's constant, and also N is number of electrons transferred.